Okay, guys, the first thing I want to talk to you guys about is linear equations. So I'm going to define them and give you guys just a simple example to start with. So what is a linear equation in one variable? All right, it can be written in the form ax plus b equals 0, all right, where a and b are real numbers and a cannot equal 0, meaning we don't just have a number, we actually have an x term. And the biggest thing to note here is that x is just to the first power. We don't have an x squared, we don't have a square root of x, we only have an x term with x to the first power and possibly a constant term. So what do linear equations look like? All right, so let's look at a few examples of linear equations. So here's one, 3x plus the square root of 2 equals 0. All right, well, x is just to the first power. Okay, it doesn't matter that the square root of 2 is in fact the square root of 2. We only know that it has to be a real number, and that is indeed a real number. All right, let's look at this second one here in the middle. All right, again, if we were to distribute this 0.5 into the parentheses, we notice that we have x to the first power, and over here on the right side, we also have x to the first power. And so, since x is only to the first power, it is indeed a linear example. And then lastly, down here at the bottom, note 3/4 x, right? Yes, that's a fraction in front of the x term, but again, x is simply to the first power. If we were to subtract the 12 to the left side, we would have something in the form of ax plus b equals 0. All right, so if those are linear examples, then what do nonlinear examples look like? All right, well, again, let's look at this first one. We see the square root of x plus 2. All right, again, that's the square root of x, not x to the first power, so we got to throw it away. All right, what about this middle one? We see that the first term is x squared. Well, since it's x squared and not x to the first power, we got to throw it away. All right, and then lastly, down here at the bottom, we have 1 over x. All right, again, you guys may not remember what that exponent is or that power is on the x, but clearly it's not x to the first power because 1 over x cannot be the same thing as just x. For those of you that might not remember, 1 over x is simply just x to the negative 1. Negative 1 is not equal to 1. So we have 1 over x equals negative 8 is not linear. In fact, we will actually learn in this first chapter what that is. Okay, let's actually look at a simple example just to kind of get us started. Over here on the left-hand side of the screen, I've given you guys kind of a step-by-step recipe. If you don't remember working with linear equations and solving for an x or some other specified letter. All right, the first step is to simplify each side. So what that means is when we look at 2x plus 2 equals 14 minus x, are there any terms that we can combine simply on the left side or simply on the right side? Well, we don't. We can't combine the 2x with the 2, and likewise, we can't combine the 14 with the minus x. So for this particular problem, we don't need to worry about number 1. For number 2, it says get all variable terms on one side and all constants on the other. So again, in the English way of saying it, what I'm going to do is I'm going to move all the x terms to one side and I'm going to move all the numbers to the other side. So the first thing we want to do is move that minus x. The way we're going to do that is to add x to each side. Okay, it's by opposite operation. So to simplify, I have 2x plus an x is going to give me 3x, and then I just copy my plus 2 equals 14. All right, to move that plus 2 to the other side, again, it's by opposite operation, so I'm going to subtract 2 from each side. And again, simplifying, I'm going to get 3x, and then 14 minus 2 is indeed 12. All right, step 3 of our recipe says isolate the variable. What that means is I need the x all by itself. Right now I have a 3 in front of it, and I need to move that 3 to the other side. So I ask myself, what is the operation between the 3 and the x? And it's multiplication. So what is the opposite operation of multiplication? It's division. So if I want to move the 3, I'm going to have to divide both sides by 3. And that's going to give me x equals 4 as our final answer. All right, let's take a look at a little bit more difficult problem here. All right, so what's our first step going to be? All right, well now we see we have parentheses. And first thing I got to do is I've got to get rid of these parentheses. So I need to distribute the 3 on the left side, and I need to distribute the minus, or some of you may think of it as a -1, on the right side. All right, when I distribute the 3, note I'm going to get 3 times 2x, which gives me the 6x, and I'm going to have 3 times -4, which gives me the -12. All right, over on the right side, I just keep my 7, and now I need to distribute this minus into the parentheses, which just makes a -x and a -5. All right, so now I ask myself, when I look at the left side and the right side, do I have any like terms I can combine, meaning just x's or just numbers? And the answer is yes. I can combine the 7 minus 5, which is going to give me 2. Okay, so now I have 6x minus 12 equals 2 minus x. All right, so again, going back to our recipe, I want to get all my x's on one side and all my numbers on the other side. The first thing I'm going to do is add x to both sides. Okay, and so I have 6x plus an x gives me 7x, and I keep my minus 12 and I keep my equals 2. All right, lastly, I want to move the minus 12. So that means I need to add 12 to both sides. That's going to give me a 7x equals 14. All right, final step here is to isolate the variable or get x completely by itself. All right, now I need to move the 7. Since I have 7 times x, the way I'm going to move the 7 is by division. And so my final answer is x equals 2.